This is an A-level pure question on trigonometry and modelling with trigonometric functions. The depth of water, d meters, in a harbour on a particular day is modelled by the formula d is equal to 5 plus 2 sine 30t, where t is greater than or equal to 0 but less than 24, where t is the number of hours after midnight. A boat enters the harbour at 6:30 a.m. and it takes 2 hours to load its cargo. The boat requires that the depth of water to be at least 3.8 meters before it can leave the harbour. Part A, find the depth of water in the harbour when the boat enters the harbour. Okay, so what we need to do to find this depth, when it enters the harbour, the boat enters the harbour at 6:30 a.m. and we need to change this 6:30 a.m. into t for the formula that we have here. Now t is the number of hours after midnight. So 6:30 a.m. is 6.5 hours after midnight. So t I'm going to make equal to 6.5. This I can just substitute straight into the formula. So the depth is equal to 5 plus 2 sine 30 times by t, which is 6.5. If I do that on my calculator, I'll get a value of d as 4.48236 and so on. Now it makes sense to give this answer to 3 significant figures, because here that would be 4 meters and 48 centimeters. We don't want to really, or we don't need more accuracy than that. And if you're not given a degree of accuracy, just go for 3 significant figures, but nothing less than that. So I've got d equal to 4.48 meters, and that answer there is given to 3 significant figures. Okay, let's move on to part B, and part B says find to the nearest minute the earliest time the boat can leave the harbour. Well, we know from the question that the very earliest time it can leave the harbour is going to be after 8:30 a.m. We need to look at the depth. That's going to help us. The boat can only leave the harbour when the depth of water is 3.8 meters, which we'll substitute for the depth here and use that to find t. So with a depth of 3.8, d equal to 3.8, that gives us this equation: 5 plus 2 sine 30t is equal to 3.8. We'll subtract 5 from both sides, so we'll have 2 sine 30t is equal to negative 1.2, and then we'll divide both sides by 2, so we'll have sine 30t is equal to negative 0.6. We'll now do the sine inverse to both sides, and we'll get a value for 30t, our principal value for 30t. So let's do that. Sine inverse negative 0.6. Make sure you're in degrees, because we've got the degree symbol there, and that gives us a principal solution of 36.8698. okay, I'll just do the first 3 decimal places. I did say negative, so I'll put a negative in there. Now if I try to solve this for t, I'll get a negative value for t, and that obviously can't be a solution, because you're basically saying the boat needs to leave even before it's arrived, which doesn't make any sense. So this is where I would use a cast diagram to find other solutions that do make sense. So here's my cast diagram: 0, 90, 180, 270, then 360. I'll plot on this angle of negative 36.869, so that's going to go over here. So the size of the angle itself is 36 point, let's just do 86, like that. Because we're solving for sine, we reflect in the y-axis, so there's going to be another solution over here, the 36.86 value. So let's work out what this solution is here. So another value for 30t is going to be 180 plus 36.86. I'll just put 180 plus 36.86 and then 9 ... Let's see what that gives us. That gives 216.869 degrees. So this is a value for 30t, another value for 30t. So we've already decided this is no good. Can't go back in time. Let's try now dividing this by 30 to get a value for t. So dividing by 30, I get 7.2289 and so on. Right, so t represents a time after midnight. So we've got a time just after 7 o'clock in the morning, at which the height is 3.8 meters. However, this is too early because the boat can't leave before 8:30, 2 hours after 6:30 a.m. So we need to go on to our next solution. So we've abandoned the negative one there. We've gone round. We've tried this solution here. It's not big enough. So we'll go around and continue. And the next solution is going to be 360 minus this angle. So let's write that down. So 360 minus 36.869. Let's see what that gives us. Put ... because it does continue. And that angle is 323.1301. Now let's have a look. Let's divide this by 30 and see what time that gives us, or what value for t. So this gives a value of t of 10.77100. Right, this is fine because this is going to be sometime after 10 o'clock. That's after 8:30. So this is fine. So what we want to do now is to change this decimal part into minutes. Now the decimal part here, which I'll just highlight in yellow, is a fraction of an hour, and an hour is 60 minutes. So I take this decimal part here, just the decimal part, and times it by 60. You can use the hours, minutes and seconds button on your calculator, but this might be a little bit quicker. So I'll take my number, I'm going to subtract 10, so I'm just left with the decimal part, and times that by 60, and what that gives me in terms of minutes is 46.2602. So this is going to be the minutes part of my answer. So in terms of a time to the nearest minute, so 10, and it's going to be AM. Now I can either give 46, I guess, or even 47. It all depends on what rounding I've done here. But my one rounded to the nearest minute would actually be 46 minutes. So 10:46 AM is going to be the earliest time at which the boat can leave, because of the height of the water is 3.8 meters.